we want to find the power series representation of this function for certain values of x, right? So we want to write an equivalent of this function in the form of a power series that will converge to this function for certain values of x. And we want to find the radius of convergence and the interval of convergence, of course. Okay, notice that this function, it will not be this power series, but we're going to use this form to find and slightly alter it so that it matches this function for certain values of x. Okay, so and it's going to be a power series representation about the constant of 0, right? So as you know, the power series can be written as x minus c to the kth power, but the c is going to be 0. It's going to be about 0. So we don't need to write the minus c, so it's just going to be x to the k. Okay, so notice that based on the previous video that we talked about, 1 over 1 plus x function is exactly this given power series. So negative 1 to k, x to the k for negative 1 is less than x is less than 1, right? So between the negative 1 and 1 for the x values, this power series representation is exactly this function, 1 over 1 plus x. It converges into this function between the x values of negative 1 and 1. Okay, so now let's see if we can change this and make it look like this. Right, so first we're going to replace the x with the x squared, right? So it's going to be, so we're going to have 1 over 1 plus x squared is equal to, let's see what's going to happen. So we're going to keep the negative 1 to the k, and then we're going to replace x squared with the x squared. We're going to replace x with the x squared, right? So it's going to be x squared to the k, right? Which can be simplified further as negative 1 to the k multiplied by x to the 2k, right? Because the power of a power means the powers multiply. And true for what? We're going to replace, remember, the x is replaced with the x squared in the interval, right? So negative 1 is less than x squared is less than 1, right? And that's true. That's the same thing as having x squared is less than 1, right? Or negative 1 is less than x is less than 1, right? Same thing. Okay, so as you can see, the interval didn't change. So now one more thing, right? We need to multiply this guy by 3 so that we'll have our function, desired function that we need. So 3 divided by 1 plus x squared is simply multiplying this power series with a constant 3, right? So 3 times negative 1 to the k times x to k, and that's true for, and notice that the interval will not change because of the constant that we multiply. The interval only changes, or the x changes, whenever the x is replaced by something else involving the x, right? So negative 1 is less than x is less than 1. So now what is going to be the radius of convergence? Okay, so we know that the interval is from negative 1 to 1, right? So we can write it as negative 1, comma 1, and open intervals, right? Because the endpoints are not used in the geometric series. Okay, so the radius, this is the interval of convergence, right? So the interval of convergence, right? The interval of convergence from negative 1. And the radius of convergence is going to be half the distance between the endpoints, right? So absolute value of negative 1, right? Because the distance from 0 to negative 1 is exactly 1, right? That's why we're taking the absolute value. Plus 1, the distance from 0 to 1, divided by 2, right? So that's going to be 1 plus 1 over 2, which is equal to 2 over 2, which is equal to 1, right? So the radius is 1, and the interval is from negative 1 to 1, open intervals. Okay, so what this result means is that between the x values of negative 1 and 1, this power series that we found represents exactly the function 3 divided by 1 plus x squared, right? Or if you want to use the term convergence, this power series exactly converges converges into the function 3 divided by 1 plus x squared for the x values between -1 and 1. Thanks so much for watching, and I'll see you in the next video.